Greetings everyone. In this podcast, I am talking performance testing with Naveenkumar Namachivayam. Let's go. Hello everyone. Welcome back to the awesome software testing and quality talks next episode. We have with us today a performance testing specialist, Naveenkumar Namachivayam. Naveen lives in Cincinnati, Ohio in United States and has been doing performance testing and engineering for the past 10 years. I came to know about him in LinkedIn, got interested in his specialization and decided to do a podcast with him. And here we are. Hi Naveen, how are you doing today?
I'm good, Venkat. How are you?
I'm good. Thank you so much for accepting to talk in the show. It's a pleasure to have you. So tell us a bit about your performance testing journey. How did you get into performance testing and how it became your passion?
Thanks for having me, Venkat, here. So I was an accidental performance tester. So I was like anybody else, right? I started my career as a manual test engineer, I think in 2006, September. So last week, I completed 15 years in the field.
That's fantastic.
Yeah, thank you. And I moved from manual testing to test automation. So at that time, Windrunner was there. So Windrunner was one of the commonly used test automation tool. Then I was working with Windrunner around 1 year or so.
Okay.
Then one day my manager came to my desk and suddenly he told me, okay, you want to do performance testing? And then I told him, I don't know anything about performance. Then learn, he told me. Okay, then I was directly put into some project. Then I don't have any idea about any tool at that time, not even any concept about the performance. I know there's a type of testing called performance, but I never seen any test cases or any test scripts. It was like a blank slate for me.
Which year was it?
I think it is around 2009.
Okay.
Yeah, it's been more than 10 years. Then the first tool I worked is LoadRunner. It was LoadRunner and it was some web application and I don't have any clue. And I just started recording like anybody else. And then I was just playing around with the tool. And at the time, right, you don't have much resources. Nowadays, we have a lot of courses. We have a pool of resources, right? There are a lot of groups. You can identify people where you can work. So at that time, it was very limited. And I don't have any clue at all. Okay. Then I started reading all the documentation and then I started exploring about basic stuffs like networking, how network works, what is protocol, what is HTTP. So those things I started learning as a fundamental. Then I started learning the tool. Actually, there was no time to learn anything because the project was due to deliver. I had only around 2 to 3 weeks. So it was like a quick stuff. Actually, I was into learning most of the stuffs. I was spending around 7 to 8 hours per day in learning. Then rest of the things I will focus on learning the application and scripting and writing some small snippets.
That's how it is usually, right?
Correct. Yeah. So it took me around, I think 2 weeks to complete 4 scripts perfectly. And I had a colleague, she was helping me in basic stuffs because she was already into performance testing. She was already completed a couple of projects. So she has some exposure on that. And then I got inputs from her. Then somehow I managed to deliver the project. So that was my initial journey started. Then I started learning more stuffs in performance because the concepts wise and also the new terms. So everything's new to me and I got attracted because there is no UI, right? Automation means you can see the UI. You can do stuff. Manual testing, again, you can see the UI and then you can do writing some test cases and you can pass or fail. So those things you can do in your spreadsheet. But performance, again, you will interact by network layer. So there is no UI testing at that time. So only the server side performance was a boom. So it was like a magic for me.
So how about logs? You would have logs for looking at the performance numbers, right?
Yes. We had at the time APM tools also. We don't have sophisticated tools to see everything. Everything is we have to go to database to see everything is working fine or not. Or we have to capture from the administrator. We have to get some logs and to see, okay, whatever we tested, it is there or not. So it's a lot of going back to and fro because as a tester, you don't have access to everything. You just have access to your application and your tool. So everything is a black box. So it is very tough to validate. It will take a couple of days sometimes. Sometimes you may never know what's going on. Only thing is you can see the resource utilization. Okay, CPU is going up when the test is going on. Memory is going up when the test is going. So that kind of validation only we can do. And the rest of the things will be validated by by the admin team. And then they will come to know, okay, there is some issue in the backend, so we need to improve. So there are a lot of communication going back and forth because the time zone, right? I was in India, most of the people in US. So again, we have to coordinate the timings. So there are managing the project was tough in the initial days.
Okay.
So yeah, that's how it got started. And yeah, later I exposed it into multiple tools, then moved to JMeter around 2010 onwards. Then I broke my internal application. I was learning JMeter and then I broke the internal system because I don't have any knowledge what I'm doing. It is like a small boy just roaming around in the playground, right? He can do whatever he wants. Just like that, I was just playing. I don't have any idea whether it will break or not. I don't have anything about the application. Then I got a mail, okay, who broke this application? Then they narrowed me to my IP address and then they asked me, okay, what did you do? Then I told them, okay, I was learning performance testing. I ran some 10,000 threads. I just added some 10,000 threads. I don't have any knowledge. Then they fixed it. Okay, there is a threshold limit they have to set. Then they identified the issue. Okay, people can attack the server. Then they fixed it. So by innocence, I broke the server and then they were able to find the issue and they were able to fix it. It's an internal application, so it is not a client application. So it not got escalated badly. But yeah, that's how I started learning. Okay, first we have to make sure what we are doing. Learning the tool anytime we can learn, but we have to be very, very thorough in the fundamentals. Then only I started learning the basic stuffs. Okay, what is a DNS? What is HTTP? What is thread? So those things I started myself learning. And then, then I started a blog. Then it's been 10 years plus now.
Fantastic. So quite interesting to note that you are doing performance testing in DevOps also. And I presume that it's done on continuous delivery, right?
Correct.
So usually performance tests take a while to get completed. So how do you manage the wait time for the results to be out in continuous delivery? Because the developers as well as the release engineers will be anxious to see the testing getting completed and proceed towards the release.
Correct. So if you are getting just started with any project, the continuous CI/CD pipeline for performance testing may not be complete. So it will take a couple of sprints to get into that full-fledged pipeline execution. In the first sprint itself, you cannot do anything much. But right now, I'm working on already, it's been going on from past many years. So what I have implemented is, I have implemented the regression suite. So basically, whenever development team checks in the code at the end of the day, it will kick off my execution automatically. And then it will just send out the notification in the Teams channel. So this is very simple pipeline I have built, but this pipeline was built not in the initial sprint. It took me around 2 to 3 sprints because I need to pick up the regression suite. Okay, which services I need to test as a regression part and what is the load we need to inject, then which pipeline I need to integrate. So this is the flow I developed, and then it's been running from past couple of years, and people were able to identify the issues if something goes wrong. So one advice what I can give to everybody is, so if you are a new project, then it not be possible on day one itself. So you need to give some wait time. Then you have to pick up the right test cases, right suite. Then you need to identify the load you want to execute, then integrate with the pipeline.
Okay, so a couple of questions there. My initial question was about the execution time of the performance test, right? For example, some of the performance tests might need to be executed for a couple of days, or probably sometimes I have seen performance tests executing a week or so because they want to find the memory leaks, things like that. When I tested performance with servers, the performance test used to take a lot of time. So my question really is, if my tests are going to take a week to complete, how is the continuous delivery going to wait for it? 4 or 5 releases every day, right? So do you run a different pipeline exclusively for the performance test, which is separate from the regular releases and then integrate later? How does it work?
Sure. So there are 2 things as a performance tester you need to build. One is the regression suite. So regression suite makes sure nothing is breaking with respect to your response time or CPU or memory. So the regular suite, right? Whatever things it's already there in production or whatever things frequently used. So those things is a separate entity. And the other thing is the new features engineers are building, and the new features should not violate any SLA. The new services will not impact the existing services, right? So the regression suite, let us keep it aside separately. We can come back to that later. But the new features, so that is what your question is. Okay, how you can make sure if 1 week is taking to complete a performance testing and how you manage, right? That was your question, correct?
Yeah, pretty much.
So the new features, so what we do is we have a 2 week of sprint. So in the 2 weeks, the first week, we make sure our scripting or test data or the environment. So those things we will take care in the first week itself. And within 5 days, we will make sure everything is perfect or available for the next week execution. In the second week, what we do is we regularly iterate our tests. So it could be manual or you can also integrate with your pipeline. So it is up to you how you want to manage those tests. But I run manually because I can keep a track of it of each run. Then I can do my analysis because I will have more time within that 1 week itself. So 1 week means we should not drag it till Friday evening. At least we should complete it by Thursday end of the day. So within 4 days, we have to keep on executing, and we have to work with the development team, architects, DevOps team, and to see anything is breaking in the new features, any changes in the UI or any changes in the payload information or test data or the environment configuration. Based on your objective of your test, so these things will vary. So assume that you are a new infrastructure, then your test needs to be changed based on the new infrastructure. Or I'm going from Java 8 to Java 11. Then we need to make sure, okay, Java 11 is not breaking our services SLA. So based on your objective, things will change, but you should be able to complete within 4 days. If you are not able to complete within Wednesday or Thursday, then you need to tell your product owner, okay, these stories will not be able to complete within this sprint. So we may need to go back. We may need to change the schedule to the next sprint. So you, as a performance tester, you are the right person to inform the stakeholders when the project will be completed and when you can deliver the results to the stakeholders.
That's fantastic. So basically, I wanted to know about the friction when the features are getting integrated and how the performance will integrate into that. Because when new features are getting integrated, there is a possibility that performance could get affected also because of the new features. If you have a large project where there are several features getting integrated on a daily basis, then there has to be a baseline for your performance testing, right? So if there are so many changes, then it would be very difficult to manage the performance testing baseline. That's what my question was about.
Correct. Actually, if the new feature is getting released, right, you can find most of the defects within a day or two.
Okay.
Because it is a new feature and development team might not embed all the things, right? They don't focus on everything. So they will just write, they just make sure everything is working fine. But the performance, they usually developers, right? The performance might be secondary for them. Performance or security, right? It is not designed in the code most of the time. So as a tester, we need to find those defects, then we have to highlight them. Otherwise, we will miss. Sometimes if we miss, then it will go to production and it will be a failure.
That's something we need to find out right away, is my opinion, because
Correct. That's what, within day one or two, you can find a lot of defects, particularly if a feature is very new, right? You can find a lot of critical defects in the day 1 or 2 itself. I have figured out most of the defects. If you see my duration, right, it will be like after the release, within first 2 to 3 days, I would have figured out most of the defects.
So these days, testing is not about just testing the developed code, right? The testing is all about getting engaged in all phases of software development, even during requirements, even during functional specifications, even during code. People do review code also as a tester. So there is a possibility that you could do a review sitting along with the developers and review the code from the performance aspect. For this, the tester has to be knowledgeable with the product code programming language as well as what the product code is doing. That's something they need to manage. But this is a model that is being followed by many companies so that the defects don't get to the code at all at the first place. So the defects will be exposed in even when the code is getting developed. And I recently gave a talk that 65% of the defects are in the requirements. So if the performance test engineers get involved in the requirements analysis and find the defects there itself, when I say defect, it's not about a bug, it's about inconsistencies or things that would affect the customers, because we have better idea of about how the product would be used by the customers. So if we know those parameters, then we can get engaged in the requirements itself to tell the product owner or the team that, there's something wrong with this and we need to get this corrected so that this doesn't percolate into the functional specification or the design stages at all. So there are several aspects from the requirements to the code in between where performance test engineers can also get involved and try to prevent the defects from getting into the code. So that's something performance test engineers can think about.
No, that's what I would love to be a part of the pair programming, right? As you mentioned, but and also in all the cases, but the reality is, as an engineer, performance testers, they don't involve us actually. That's the reality.
So this is a process problem. This is not a
Correct.
technical problem.
Correct.
When you say they don't involve, so from my experience, actually, how we do that is, you need to have a strong leadership team on the testing side also, who can basically talk for the testers or talk for the testing team to make sure that test engineers are getting involved right from the front, or at least the test lead should get involved. If not the test engineers, the test lead should be there, or the test architect should get involved in the requirement stages. I know that this is a process problem, but if you want the defects to be detected earlier, then it's a must that testers needs to get involved in all these phases.
I agree, totally agree with you. But the reality is most of the projects will not work like that. And performance, whenever there is an issue in performance, right, then only they will track back the testing team. Okay. If everything goes well, no one cares where you are, who you are. But if there is a problem, then all the eye is on you.
So that kind of environment has to change. That can change by building relationship with the developers and building good working relationship with the overall team, like the product owners, business analysts. That needs to be managed by test engineers also to some extent. And there should not be any silos, in my opinion. You should be able to go and talk to anybody, like business analyst who is collecting the requirements from the customers or the target audience. Go talk to them, figure out, how the product is going to be used by the customers. What are the performance criteria? For example, if you have a web application, that might be a requirement saying, I need to have 10,000 users logging into the website at the same time. So, exposing things like that, reviewing the requirements document if one is available, getting involved in BDD, all those things will help. So my advice would be to do that. But reality, as you said, could be different. But eventually, slowly, test engineers have to start doing that.
Agile, right? Everything is changing. Everything is fast, right? Yeah, nowadays, as engineers, we need to involve, as you said, right, with the architects, with the development team, the product owners. So we have to nurture the relationship. Then we need to involve early ourselves by writing some stories or get some information. Then we should know what's going on in the architecture and the application.
Absolutely. Things like BTD, right? When you do the example-based thing of how the system should perform, then it directly gets translated into tests that you can execute in the pipeline.
Correct.
And when you write the BDD test, there is a lot of conversation that goes on between the product owners, business analysts, and the test engineers, and also the developers on the behavior of the system.
Mm-hmm.
So at that point of time, test engineers can get involved and give their feedback, if something is not right.
Yes, I agree. Yes. I don't know about whether it has a use case for performance. I never tried it. Actually, I need to explore on BDD from performance testing perspective. I need to read more about that.
In fact, you should try to explore whatever you can do with BDD. Performance, security. When the requirements is collected itself, we can do analysis of performance and security related issues using BDD. And that would save a lot of time, even before it gets to the design stage.
Got it.
So, great. So what kind of performance tests that you do? Because I know that you do load testing with JMeter a lot. I have seen your LinkedIn profile. I have seen your YouTube. What other types of performance tests that you do? What tools do you use for them?
So typically load testing. So load testing help us to study the behavior of the system under the normal load. So that is the commonly used type of testing we do every day. Apart from load testing, I involve myself in the stress testing, where I need to figure it out when the application is breaking, or CPU or memory. So whatever things you want to break, you gradually increase the load and try to study the behavior and see when it is breaking. So load testing, stress testing, again, common types of testing. So apart from this, we do endurance just to see any bottlenecks with respect to memory. We run for around 6 to 8 hours. But not regularly. It is based on need basis. But load and stress is most commonly used type of testing in our day-to-day life. My endurance is a couple. It means a monthly once or twice kind of testing. So these are three common types of testing I do. And most of the tools I worked with, LoadRunner we were using in the past, but nowadays more into JMeter and NeoLoad.
Yeah.
So these are tools I work regularly. But apart from that, I myself learn other tools like K6, Locust. So those things I learn regularly myself.
Fantastic. Great. So tell us about performance monitoring. To be precise, tell us about your performance monitoring experiences. Do you monitor in the production? If yes, how do you collect instant context information that's relevant to the issue at hand? So the predetermined metrics may not be sufficient at all the times, right?
Correct. So, but most of the time I work in a non-production environment, because that is my scope. Most of my scope is a non-production environment. Okay. But in few instances, we monitor the production dashboards. There is actually a team, right? SRE and DevOps team. So their job is to make sure production is not breaking anything. So first respondents will be there, DevOps or SRE. But occasionally, I also, every week, I just go to my dashboard and see if something is abnormal or not.
Okay.
But when it comes to stage environment, I regularly monitor. Whenever test is going on, we monitor, and then we use Dynatrace extensively. From past 7+ years, I've been using Dynatrace, and for briefly, I have used New Relic and Splunk. But any tool, doesn't matter whatever the APM tool you are using. All the tools, most of the times it works in a very similar fashion, where you get a dashboard, you can deep dive into where the issue is and which layer is causing some problem. So most of the tools gives some similar picture when you're trying to observe things. And so when it comes to stage performance, what we do is we created a sophisticated dashboard for our services, and it has a lot of components. And whenever the test is running, it will give you some clear picture. Okay, where we need to focus. Nowadays, again, we have Kubernetes, containers, things, right? Again, it will dynamically, it will show the dashboards in a right way, and then it will alert us. And if something needs to be deep dived, again, we have to deep dive into the particular layer and see what's going on.
Okay. But the deep dive would take a lot of time, correct?
I mean, if you are already know things around within your project, it will not take much time, I would say. But if everything is new to you, yeah, you may need to spend time on learning the architecture. But maximum 30 minutes to 1 hour for a similar, very typical problem, you can figure it out. But if something is not able to reproduce, or something is crashing unknowingly, right, then you need to further deep dive. It may take 1 day or 2 days, or sometimes 3 days. So it depends on the context of the problem.
Yeah, so I'm worried mostly about the context of the problem. It's not about the engineer not being experienced in the product. It's about, let's say, a new problem came up, which cannot be captured with your existing metrics. For example, CPU, memory, whatever you are looking at. If you are not able to detect that problem based on what you are looking at already, if it's a new combination of parameters, correct? So in that case, even if the engineer is pretty experienced with the product, even if they have been working and they by the gut feeling know what's going on, they may not be able to figure out what's going on with the system. Then the deep dive becomes really difficult. So that's where I was coming from.
Correct. So yes, in some instances, I have everybody would have faced with this situation. So usually, my way is I don't spend on a particular problem for more than 2 to 3 hours. If something is I'm not able to figure it out what's going on, then I need a fresh set of eyes to see the dashboard. Because if you keep looking and if not able to figure it out, then it might be a very small problem or it might be a very, very big issue. Okay, for example, it could be very small config change, which we may not know unless you see the configuration parameters. Right? Okay, what is the change in the parameters in the previous run and today's run? Then we need to compare all the parameters and its values. If someone changed, then that could be the issue to your problem. So this one is easily you can figure it out. But if something you're not able to figure it out, even after spending 2 to 3 hours, then it is a good idea to bring a fresh set of eyes. For example, it could be your development team or it could be a DevOps team. Then bring them and ask them, okay, what you are seeing. So they can collaborate with them, and then you can somehow you can get some idea. Then you can take the remaining steps from there. So that thing I follow regularly, and I try to compare everything with the previous snapshot. So that's what I do. Okay, what has changed? So that is what I try to figure it out.
Yeah,
even if thing has changed, then I try to reproduce with that change.
That's a good debugging strategy. Usually when we try to debug something, then we usually look at what changed. And
correct, because by identifying the change, right, you can easily reproduce in sometime. If you have a time, you can reproduce, or you can flip back, you can revert the change and then you can run the test.
Yeah.
And even if it is not able to figure it, okay, I have reverted, then still there is an issue. Then again, I see the traffic pattern. I validate my scripts. If something is wrong in my script or test data or whichever component is causing this issue, again, we need to further deep dive with the help of the team. Actually, recently, right, I have faced this issue with respect to cache. So cache, again, most of the people, right, they might not debug on the cache layer. But the issue was with the cache layer, we were not able to figure it out. Even DevOps team or myself, we were not able to figure it out. So we have to deep dive by taking a snapshot of memory. Then we were able to identify, okay, it's a cache layer. So it took me 1 day. So you may not know where the issue is. Even a small thing might cause a lot of trouble.
Correct. There is a lot of talk about observability, right? When it comes to performance, what is your experience with performance observability? Because they say that it's better than monitoring, and if you're able to observe in a better fashion, then it's great. So have you dealt with before, and what is your experience?
Yeah, recently we started. It's been, I think, 6 to 7 months, I believe. We were moving from on-premise to Kubernetes infrastructure. So in Dynatrace, again, it will give you the tracing information in the dashboard. And I started exploring and learning more about observability. And myself, I engaged in learning OpenTelemetry, OpenTracing. So there are a lot of frameworks, right, merged together, formed OpenTelemetry. And I started learning observability tools like Jaeger, and then Signos, Instana, Dynatrace. So those things I started learning myself. And from my perspective, observability, it is a kind of superset of monitoring. So monitoring, I want to monitor CPU, I want to monitor memory. So the things you expect goes wrong, right? So that thing, it fits under monitoring. But when it comes to observability, nowadays, everything is distributed and microservices architecture. Everything is scaling deep, and you may not know how many pods are running at a time, right? How many containers you are running at a time. And on the fly, if you want to get to know about your internal systems, then comes the observability. And you can, by seeing the dashboard or by using the AI ops, you can identify the problems pretty much quicker. And then within a short period of time, you can fix the issue.
So tell me more about AI ops, because again, it would depend on the past data to see if the new problem is related to the past data, right? That's how AI works. How effective is the AI ops in detecting the problems?
So most of my focus is on stage, right? So I never worked on production.
Okay. Okay.
I don't know whether the AIOps is enabled in my project or not. I'm not sure. But based on my readings, AIOps is like might have a self-healing capability. For example, if the things say some of the resources going up and it needs more space, right? So AIOps could heal the problem, and then it can bring the things back to normal. See, AIOps again, it removes the silos between the DevOps, SRE, and the development team. Okay, so these are some of the features I have read about AIOps, but I never really into the AIOps yet. I'm just getting started with observability.
Okay.
Then probably in May, and after 6 months or 1 year, yeah, I may have idea about how the internals works in AIOps, frankly.
Sure. What about performance engineering? Nowadays, it sounds like it's a fashion to add engineering as a second word of anything and make it cool, right?
Correct.
So is performance engineering a thing? How is it different from the existing performance-related development and testing activities? If it is the same, then what is the need for a fancy name like performance engineering?
Performance engineering is there from past many years. So from me, it is a superset of performance testing.
Okay.
Performance testing, as an engineer, as a tester, what we do, we create scripts, we execute, we gather report, and then we see what's going on. We analyze the report, then we share the results with the stakeholders. But that is not enough, actually. You have to give more insights about your run. So that is where performance engineering skill comes. Okay, why the response time is high? Why the resource is taking a peak? So you need to answer that why part. As a tester, you can give you only the what part. Okay, what is my response time? What is the CPU? What is the memory? What is the throughput? What is the past transactions or file transactions, right? So the what part comes under performance testing, and why, how can we improve further? So those questions, if you can answer, then you are an engineer.
Okay. So usually the why stuff is handled by the developers, right? Testers don't get that much involved in the why part, correct?
No, I disagree actually. Sometimes the development team might not have any clue, okay, why there is a response time is increasing when the load is increasing. So we may need to deep dive as a tester, right? You can deep dive, and then you can recommend some of the tactics to the development team. For example, thread lock is happening. Okay, why thread lock is happening? So you can just do some white box testing and see, okay, this is how thread lock is happening. You can give some insights to development team. So again, depends on the problem you are seeing, and then based on your knowledge and experience, you can give some recommendations to the development team.
Okay, so what kind of nasty performance issues have you seen in production? Or can you give us some details about some very bad performance issues?
Production, yes. If it is a very new application, yeah. In production itself, I have figured out a couple of issues. So mainly they don't optimize the JavaScript libraries. So without compressing, they just have the uncompressed version, which will take a couple of extra seconds to download and execute. So those things I have seen. And caching mechanism, again, they mess up the caching stuffs configuration. So that issue I have figured it out in production. And mainly the payload information. So they will be sending a very big, heavy payload at one snapshot. So that we have figured out. We have solve that issue. Okay, we have to do a multi-part, or you have to take some different approach to fix the payload. So these are some commonly known issues. We are able to figure it out. Actually, this happened in production, and we were able to find, because in stage environment, we kind of limited when it comes to test data, right? The test data is like we don't have any control on the test data. We can have whatever things we can send, we can test it in a stage environment, but production works differently. There could be some limitations. There could not be limitations. So things work widely in production. So extreme cases, yeah, we have figured it out in production, and then we are able to fix it.
Excellent. So quality is measured by customer satisfaction, right? So what are customers looking for with software performance usually in your experience?
So everything should be under 1 second. Whatever you do, whatever you see, everything should be 1 second. It should be interactable, basically. Whenever you are able to, okay, there's a good deal is going on. Okay, I should be able to click on add to cart. Then add to cart should be clickable. I don't care about other steps. In the back end, you can still load, right? That experience people expecting. I'm also an end user, right, for any product. So I expect things, okay, it should be interactable when the things loading, particularly under the peak load. Mainly, for example, it could be some Black Friday deal, or Diwali sale, right? And say health enrollment. So these are the events people tend to access the website at the same point of time, and they want performance. So the experience and the data wise, it should be using very optimized data. Nowadays, people are accessing from mobiles, and just like that, you cannot send MBs of data unnecessarily. So the data part also, the backend should optimize. Whichever things is required for the end user, it should display, and then it should be interactable. So that is what my expectation is.
Fantastic. So thank you so much for taking time for talking to me on the software testing and quality talks today about the performance issues. Do you have any questions for me, or do you want to tell anything specific to the audience?
Yeah, thanks, Venkat, for having me here. Yeah, one quick thing is, if you're getting started, if you're planning to dive into performance testing, first learn the concepts, performance testing concepts. Then you can learn the tool. Tool you can learn at any point of time, but the fundamentals is the inception. If you learn one tool, again, don't stop with the one tool. Try to learn at least a couple of tools, which will be very helpful in your career. Thank you. Thank you so much. Thank you once again for your time and expertise. And I look forward to talk to you in future also regarding specific performance related topics. Thanks, Naveen, and have a nice day. Thanks, Venkat. Bye-bye. So folks, hope you enjoyed this podcast. What are your thoughts on performance testing? What are your experiences in performance testing? Is there anything that you would like to suggest as improvement in the techniques or tools that were discussed in the podcast? What would you like to share with the software testing industry on performance testing based on your experience? Please comment below in the video and let us know. Naveen or myself will respond back. Don't forget to subscribe to this channel and hit the bell icon. Thank you so much for listening to this podcast, and see you again soon.